at its full. So now going on what we have done so far, based on the initial material groups that were identified even prior to the start of the project, what we've firstly done, we've collected all the data that it's locally available because on paper, the data regarding how the waste is being collected should be there, but what we figure out is that it's not that easy to get this data, at least not in the format appropriate to be further analyzed. So yes, a lot of effort had to be put into collecting the data, to get the data where the waste is being generated, where it's being used, how it's being processed. And this was what we first looked into in the first part of our project. Then, based on this data that we've collected, we've narrowed down the materials we want to look forward into. We used a specialized tool called GDSE, which is a Geodesign Decision Support Environment, which is used to simulate the workflows. If you will follow our events, you can also see some more detailed demonstrations, but it's quite impressive. You can see in how the actual material flows are going in different countries. It's a really nice simulation. Then, based on this data, we narrowed down even further. We performed preliminary laboratory tests, and we figured out which materials bear the potential. Mainly, we have focused which materials can really be made inert, because the environmental aspect cannot be put in danger. There is no tolerance there. The materials that are installed have to be environmentally suitable. There can be no doubt about it. I've already mentioned the one-stop shop. I've just devoted one slide to one-stop shop because we are organizing a lot of events, and if you find it interesting, please, you're all kindly invited to join us to test the tool. There will be some events later on this year. So if you follow us on Twitter or Instagram, you will easily find the links to these events, or you can also contact us directly. But just to give you a brief overview of what we are trying to do here, we are really trying to put all the information needed that somebody needs when trying to go more circular in one place. We are collecting and presenting the market opportunities, the legislation that needs to be considered, the standards that needs to be considered when somebody tries to get more circular economy, the circular economy business models into the practice. We are also promoting the construction, the products that are already available, that are more circular, that are made of the recycled materials and so on. I wouldn't go into too much details. If you have some questions, you can ask me later on. As Vlado said, the focus of today's session should be more on the actual development and the testing of our solutions in large scale. So later in this presentation, I'm going to go a bit more into details. I cannot be too specific, but just to give you a rough overview. So here are just some materials that we are going to use in the demo construction project. So we are going to use fly ash, foundry sand, and the previously mentioned crushed plastic of grain candles to produce green concrete. We are an important material that has proven to have economic potential is reclaimed asphalt pavement. This we can use this to produce new asphalt. We can use it to produce lower load-bearing layers in the road construction and also other construction products. Then we are looking into the way how we could recycle the heavy fraction. I've already mentioned it here on this picture. You can see this is basically the material that cannot be used for anything else. But the construction sector has the potential to use it because there are vast quantities of these materials, and if we make it inert, we can make the construction products that can be used to revitalize areas, etc. Then in North Macedonia, as you will see later on, we have identified two products that have a huge potential. These are the byproducts of the steel production process, the so-called white slag and black slag. You can get more details by getting directly in contact with us, or if you look at some of the papers we've submitted so far. Yeah, but in Macedonia, there are huge quantities of these materials that is really that really bears a huge potential to be used in especially in road construction projects. Here are just some pictures to give you an idea what have we done so far. For those of you who are not that familiar with construction project developments or construction product developments, and if I'm speaking on a laboratory scale, we do not have small scale laboratory mices, but we have bigger machines. But compared to the real demo sizes, these are still small scale machines. Yeah, we have to do first small scale demonstrations to make sure that, for example, the concrete has the load bearing capacity, that has the properties that so that the concrete can be installed in practice, that there are some additives. Do we need to add them? So yeah, it's a whole scientific process of constantly testing, producing, optimizing, and we've done a lot of progress on this regard. So now we have a list of materials that we will actually use. Besides these large-scale construction and construction projects, there is also another demonstration that is taking place within the CINDERELA project. It's a small-scale demonstration project where we try to extract phosphorus in a urine container, in a container. I won't go into much details because you can find more about this in the promotion materials on our website, and I'm also not expert in this field. You can get in touch maybe directly to me or to our colleagues from TU Delft. I just want to mention it because there are various aspects of circular economy that CINDERELA covers. But what is more important, we are also looking into how novel materials can be also 3D printed. The IT aspect and the IoT, the IT aspect and the construction 4.0 is also an important part of the project. So yes, we are also looking into the beyond state-of-the-art technologies, on disruptive technologies, how they can make the construction process more sustainable. Coming back to the sustainability assessment, I've already mentioned we are doing the LCA, LCC, and social LCA analysis. Let me stick here just with the social LCA analysis. This proved to be an important aspect because we've identified, while trying to get the permits for the large-scale demonstration projects, there are some concerns when one tries to use the recycled materials in construction projects. So events like these really have to be held that we persuade that our products are good both on the short run as well as on the long run. We have to really raise the awareness of the local community, of the engineers, of designers, etc. So yes, I would like to emphasize that social aspect of circular economy is also an important one. So going more to the practical point of view, once we've done the laboratory scale demonstrations, we started to plan the large scale demonstration. Here is a schema how this pilot production is organized in Maribor. Probably you cannot see this the whole signs on all of these boxes, but let me just briefly summarize it. One thing is that we have to make sure, and what is really challenging is to try to get the material while we collect it to our processing plants as pure as possible. It's really hard to process it if the material is really mixed. While I'm saying mixed construction and the demolition waste, yes, it's mixed, but there are some materials we really are trying to avoid to be present because they can really reduce the properties of the final product. So then there is a whole process. We have to crush aggregates, we have to separate aggregates. You will see later on how this is done on the real side. And then there's a last part before we can put our final products to the market, is the certification part. So it's really important that that all of our products have the certificate that they are okay from all that they are all okay from all aspects. Here is another slide. We also we heavily rely on take advantage of the environmental on the IT that is available. Here is just a scheme how we of the planning process of our demonstration sites. So yes, we first collected the documentation. We've used Autodesk Revit, we've used Civil 3D. We've developed the previously mentioned BIM libraries which hold all the attributes so that we can make the simulations in virtual environment that our solutions are sustainable. Then for this we use the product so-called Bexcel Manager. Bexcel is also one of the partners, and they are making the simulations so that they can do the 5D simulations that really prove that that really support our idea about circular economy being economically viable. Now, coming back to the large-scale demonstrations. I've spoken roughly about circular economy business model, about the waste flow analysis, the SRM-based production, now we've come to the large-scale demonstration. There are basically the large-scale demonstrations are taking place in Madrid, in Spain, in Northern Macedonia, and in Slovenia. In all three demo sites, we are going to build a small facility. We are going to build a small section of a road, and we are going to revitalize a small degraded area, just to do a proof of concept that our solutions really are applicable in practice. And here I have to mention once again that we have industrial partners involved in these demo cases, who have to contribute their own resources to implement this demonstration. So yes, we believe we are on a good path towards proving that our solutions work. The construction activity. So we are really focusing on all aspects. First, we started with design phase, then the pre-construction activities. We've done some on-site surveying, then there is an actual construction phase. And we are also looking forward into how our products will behave over their lifespan, and how we can recycle them once they will be once their lifespan is over. So yeah, we really have to take into consideration all of the aspects of the lifetime of some construction products. Let me skip this slide, but yes, I've already mentioned the simulations. Yes, we've really used take advantage of BIM to really calculate what quantities of materials which will be needed, and this data is also a valuable resource to perform the Lca analysis. And to really, this is something I would also like to emphasize. If you're using unconventional materials, one thing is to test it on the laboratory scale, but another thing is to really test it on large scale. And in order to make sure that it really behaves the way you predicted it, you have to make install some sensors. And here is just an overview what kind of sensors will be installed in the road that is going to be built in Maribor, and how we are collecting the data, how is this being then collected to a so-called digital twin. I've just recently published a scientific paper regarding this. I won't go into details, but you're more than welcome to read it and share it. Going back to demonstration in Maribor. So here is just a bird's eye view or a large plan what we are doing. So we are building a road that is roughly 400 meters long. We are building a small facility, and here there used to be a dumping site for the construction and demolition waste, and we are revitalizing this large area. Here on this side, you can see that some pre-construction works have already been done. This is another bird's eye view picture of just to give you an idea about the scale of the project we are doing. Yes, so here on this side, the pilot construction is already being established. This is a more recent picture. So we have a mobile concrete mixing plant where we are testing our solutions in practice. Just one more figure maybe to point out to give you an idea about the scale of the project. So we aim to recycle 18,000 tons of materials in Maribor alone. Here are some more pictures from the construction site. Of course, all the materials cannot be recycled. Some of rebar, I mean, we have to use it, but the concrete slab, the base slab, was produced from the green concrete, and this was produced from the construction from the recycled concrete with some additives. Then what I would like to emphasize, we are making the construction, this small facility modular. We are using the prefabricated modular block that looks like similar as to some sort of Lego blocks. And what we've figured out, they are not only able to be used in the facility, they have proven to be even more useful as separating units for the storage boxes. So yes, this is one thing where we really know that they can be exploited on the long run. Here are some more pictures from the construction site. So yes, we are using the concrete blocks made out of recycled materials to construct the facility. To give you maybe some more technical details, what are the challenges that we are facing, or that all is not that simple? Here is the picture from Macedonia, where we are using the previously mentioned black slag for the road construction. So one challenge is it is really important that we stay within the, this is just, let me emphasize, this is just one of the properties of the material that has to be met. It's maybe the sieving curve is just some basic property that has to be met if somebody is to use the material in the road construction. So a whole technological process needed to be prescribed, how to process the waste to achieve the, stay within the limits. So yes, there is a whole technological process behind it. The material has to be sieved many times and mixed many times to produce the final mixture that is appropriate to be installed. Here's just a site from a picture from Macedonia. There is a large degraded area, and we aim to build this, we aim to revitalize it, and here we plan to construct a plateau for the trucks, a big parking space, basically. Here are some pictures from Spain, where we are trying to prove how this construction and demolition waste that was that we've got from the demolition of large kilns can be used in new construction products. Also here we are producing green concrete and some products for the road construction. This material is also being crushed. It has to be sieved, separated, then mixed, and then it can be installed in the road construction projects, both in the lower load-bearing layers as well as on the concrete top layer. Yeah, so this is basically all that I have prepared for you so far. Please feel free to stay in touch, and by us, you can get in touch directly by email to me. You can visit our website. You can follow us on Twitter and on LinkedIn. Yes, this is basically all I have prepared. So now I'm open for questions.
Sebastian, thank you very much